So yeah, welcome from my part as well. My name is Oskar Ehnström. I work here at Futurice as a developer, project tech lead, what have you. It depends a bit on what the client needs. Usually my title changes based on the proposal we're doing. I'm going to have a talk today about how not to build an API. This is not very Google specific, but I do have some Google references in there. It's mostly just about good practices and even more about the bad practices that you usually see when developing APIs. A lot of this is just general good practices for software projects and services, but I'm not going to spend any time on any UIs, so it's mostly actually about building APIs. Now, this is a lot from a consultant point of view. So if you work in a product company, this might be a bit different, but you might be able to see sort of from my point of view how it feels like to join a project and work on an API, especially one that's not built to be nice to work on. And as a note as well, like this is not from any one project. This is from various projects that I've worked on or that my colleagues have worked on or that I've just discussed with people about. So there's no one client or one service or anything like that in here. Nothing is this bad all in one. It's like a collection of stuff. And if you have any questions, just feel free to ask them at any time. Let's see if this one works. Maybe? No. Did I lose my speaker notes? Yes, I did. I should not have said that everything went fine in the beginning. All right, let's not use that then. Anyway, so as a consultant, when you join a project, you're usually, this is from a developer point of view, as a developer, you join the project and you get to see the service that you're supposed to work on. And it's a bit actually like being a property developer because you arrive at this house. It might look like that. It's a bit maybe haunted. You don't really know what's in there. But it's your job to make it work. Just turn it over, make it beautiful, make it functional, do everything that the client wants. Usually it should be done yesterday and very cheaply. So you join the project, you see the house and you're like, oh no, what do I do now? And of course, you're looking for instructions on how to do this. With a house, you usually don't get instructions, but with a service, you get instructions because you can read the README. Except usually there's no documentation. So you go into the project and you're looking for that readme.md file where you can see exactly like why was this done and what do I need to set this up and just practicalities on do I need to have any environment variables or something like this. Like what is the minimum set of steps for me to get this running on my machine so that I can get this feature developed as quickly as possible. Well, if there isn't any documentation, there's not much you can do about that. So then you need to start reading the code. And the good thing about, this being code is that anything it does is defined in the code. So you can just go read the code, but this is going to take a long time. So it's probably much better if you have that documentation. But there are things that are worse than no documentation. And that's invalid documentation. Because with no documentation, okay, I need to read the code. Like you can communicate this. You can tell the team and you can tell the product owner, there's no documentation. I'm going to have to spend a week on just learning what this is and what it does. But when there's invalid documentation, then it looks like everything is fine. But then when you start running it and you start following the steps in the README and downloading all the things that it says you need, then at some point it's just not going to work. And then at that point you don't know, is this my fault or was this is this supposed to happen? Is there something I need to do? So Invalid documentation, much worse than no documentation. Like if it describes what it does, and then you try it and it doesn't do that, it does something else, then that's much worse. And if you have links that don't work, there's like relevant documentation somewhere, but they don't work anymore, then you don't really know what you're supposed to do at that point. With no documentation, it's clear. You read the code. With invalid documentation, yeah, you just don't know. My tip for this would be to just write the bare minimum that you need and just refer to external documentation anytime there is some. You don't need instructions on installing Node or like the JVM or stuff. Just list them. You need Node. If you need a specific version, list that as well. You need like this version because that's going to read the package file and then everything's going to be fine. But just don't start writing out long instructions in the README because then updating that is going to require a PR and stuff, and it's just not going to happen. So just keep the README to a bare minimum, and if you have more documentation that you really need, use a wiki or something like that for that. So the README is not the place for all the documentation, it's for the minimum documentation that you absolutely need and that you can keep up to date. So anyway, okay, documentation. You know what you got, now you need to run the application. Except master is broken. Yeah, you know this. I can hear people laughing here. You know this situation. So you pull down the code and you're like, yes, okay. npm start, and then boom, everything just explodes. And then this combined with not having documentation or having invalid documentation, it really kills your morale. Because you don't know what's wrong and you don't know if it's your fault or if it's actually broken or if you just need something. Again, like maybe you need like an environment variable, there's some configuration that you need to have something in your session. You just don't know. And this like when you think you got it and then you don't, that really kills your motivation to do anything about it. So if you have some specific things, put them in the README, like JVM version, Node version, stuff like that. Just put it in the README so you know, okay, this is supposed to work, it does or it doesn't. Then you can start fixing it. And when you fix it, document it for the next person. Countless times I've seen this, and then there's like 5 people telling me like, oh yeah, you need this and you need that, and then just run this command and everything will work. I'm like, why is this not in the README? Like there's some other instructions there that I just ran and it didn't work. Like why couldn't you just update it when you found out how to work it? Or in another project I saw, there were like 5 different instructions on how to run it, and that's equally useless because you're like, well, which one is the correct one? Like this one has to use the local profile and that one has to use the dev profile. Yeah. Then maybe you check the Git history to see like which is the most recent one. All right. Anyway, so you get the thing running and then you want to start coding. And then there's no tests. And here, like the most important thing to remember is run the tests first, because nothing is worse than coding on your feature and then, oh, did I break something? I don't know. Like there's no way to check. So this is why you have tests, is to check like I'm developing this new thing. Does it work? Yeah, okay, fine. That's easy. You can check it. Like the specs are correct. It works. But did I break something else while doing it? That's the sort of place where you again have this uncertainty. So that's why you need tests. But again, like, okay, most of these things are things that all of you know. Like this is not something new that you didn't know about before. You know all of this stuff. And still this happens. I don't know why, but maybe it's just that you forget or something. But yeah, all of this happens even though it's not complicated. One more thing about tests. What's worse than no tests? You can probably guess this. Broken tests. This is the same as with the documentation. When you don't have it, you know you don't have it. With no tests, you know, okay, I need to make sure like this doesn't touch anything else, and maybe I can write some tests before I do this. But with broken tests, and especially if you don't run them before you start coding your feature, then you can spend days trying to figure out how you could possibly break that test, just to have someone again tell you like, oh yeah, they've been broken for a year. You laugh, but this happens. This is not fiction. This really happens in projects quite a lot. It's like you work on something and you run the tests and you're like, oh no, I broke everything. And you spend like, especially if you're a junior developer and you're like, you think everything's your fault. And so you start fixing it and then you're like, oh no, they're gonna find out I don't know how to code. And then you ask a more senior person and he's like, yeah, we should really do something about those. There's so much uncertainty in this. Okay, again, keep documenting. If you know the tests don't work, just add comments in the code, in the README, just somewhere so that when people stumble upon this, they see, okay, these tests are not supposed to work. Like they haven't worked since we moved over to this new system. So then at least the next person coming after you knows that these are supposed to work, these are not supposed to work. Oh, and again, a pro tip. If you have been developing your feature in your feature branch and then you run the tests and they break, just pretty quickly switch over to master, check do they work there. Because a lot of the times what happens is you go to your feature branch and you code and then the tests break and you think, okay, this is my doing, but then on master they're broken as well. So just switch to master, clean out your working directory, run the tests to see if it's actually your fault or someone else's. So, you know the test situation, time to start working on a feature. You go back to your haunted house, you want to develop your feature, you go in and you start investigating what's what. This is the part where it's like, you know what's happening. It's code, it might be complicated, but it's just code. You can just start looking through, start, command clicking to see this goes there, this goes there. And then you hit on the next scary thing, over-engineering. This is especially coming in as a consultant and not knowing really what's going on, and then you start figuring out the code and you're super happy to get to the place where you're just looking at the code. This also really kills your spirit. And this quote I actually just found today, this law, it's I think really good. Kernighan's law. Debugging is twice as hard as writing the code in the first place. Therefore, if you write the code as cleverly as possible, you are, by definition, not smart enough to debug it. This also rings true, right? You stumble upon some code where you see, okay, this person clearly just found out about, I don't know, Scala implicits or Spring decorators or something like this. And they're like, oh, use this everywhere, like implementations everywhere. That's one of the worst things coming into, for example, an old Java code base, is just finding implementation, like not finding the implementation, just finding sort of the trait or something that defines what it's supposed to do, but never actually finding the logic that does it. For example, in Spring, there's a lot of, this just happens by magic. And yeah, okay, sometimes that's cool, you don't need to write that code yourself, but you also don't know what it does. So you need to at least document, like this is the principles in this project. We let these libraries handle these sort of magic things, and then everything just works. You can't just sprinkle decorators everywhere and assume that everybody knows, like this decorator is part of Lombok and this decorator is part of, I don't know, something else. Scala is not much better with implicits, for example. You can just have implicits somewhere way high up on the chain, and then right in the code, it just appears, and you have no idea where it comes from, and IDEs have a really hard time figuring out where something like that comes from. So yeah, abstractions all the way down, that just kills your spirit, and just having magic in your code. This is something that we can debate later if you want, but I very strongly favor the KISS principle of just keep it simple. Just make it explicit, because computing is cheap. It doesn't matter if your code is a tiny bit more performant because you did it with lenses and shit. It matters if a person coming after you can understand what you're doing. You should not break other developers' minds. Like I was talking to a former colleague, and she had been staring at this piece of code for like a week, trying to figure out what it does. And when she finally did, she was like, it sort of broke my mind. Like she was just walking around like her world expanding in some weird way. Like this is not a concept that had existed before and now it does. Like just keep it simple, especially when you're just there to do the job well. You need to sort of help other people do it after you as well. And if you do something fancy, it might actually be the best solution. Like, there are times when you really do need to make that complicated solution. Again, just document it. Just put something there like, this is why this is done in this weirdly complicated fashion. That has also happened. I've rewritten some code and then been like super happy. And then after 3 or 4 testing rounds, I go back to the original implementation because I just didn't realize how complex the domain was. And then I added a comment like, this is done in a very complicated manner because all of these reasons. All right, so once you're getting over this over-engineering and you understand it and you can sort of implement your feature, you're finally done, you're super happy, finally, my feature works, yay! And then you hit on some broken linting. Now this is super annoying because your code works, everything is fine, the feature is exactly as the PO wanted it, and then you go to push it, and then either a push hook or some CI machine is telling you like, no, this is wrong because your formatting is broken. And don't get me wrong, I really like automated code formatting. I think it's a great thing because everybody has different opinions on how exactly to format the code. So if we can just agree that everybody is wrong and we just follow ESLint, then everybody's much happier. But the problem is when you have broken linting, when you have something that's defined in one way in some place and in another way in another place. For example, the worst is if you have an IDE or editor doing linting and it's doing it a bit differently, like compared to a pre-push hook or something like that. So linting is good, but it's one of those things where it really needs to work 100% of the time or it's completely useless. Because if it doesn't, and you sort of start adding PRs with just linting changes, it's going to be impossible to review those PRs. Anyway, you can fix this. Just edit the configurations. Make sure your editor uses the same version, all of that stuff. And then you push your changes, and there's no CI or CD. And this is a bit unfamiliar to me because we always have that. We always have something that checks your code before it goes to deployment. But I mean, I guess it doesn't happen all the time. And this again creates uncertainty. It's like it works on your machine, but the reason you have a CI/CD pipeline is to make sure it works everywhere. Like there's a clear documented setup and it's documented well because it's defined in code. That's the sort of documentation that can't be wrong because it's doing exactly what it was programmed to do. This is good if you have a feature and you just want to push it, but then it's still going to be that bad feeling about, did I break something? I'm not sure. So I really just, if there isn't some CI/CD pipeline, that should be on your top list to get done. And by the way, Google reference, since this is a Google meetup, they have a really cool thing called Cloud Build. So for example, you can just use that. So if you're working in, let's say, Google Cloud, my favorite cloud, it actually is. The UI is great compared to the other ones. You can do everything inside basically all of the clouds nowadays. So you don't necessarily need to have GitHub and Travis and Heroku to get a good experience. You can do it inside those clouds. That's what we did in one project where it was super hard to get Bamboo agents configured correctly and all sort of crap like that. We just did it ourselves inside our own AWS account and then nobody cared. So I highly recommend doing that yourself if you can't get a proper system to do it. All right, so you have your feature, you realize there's no CI/CD pipeline, you write that as the top sort of to-do list on your item, and then you push your code. And then production isn't the same thing as what's running in production isn't the latest master. This is something, when I had this talk earlier that came up from the audience, and I realized, yeah, this does happen sometimes, and it can cause some really weird issues where someone has deployed production and then continued working on something and like merged branches to master and stuff like that, and then they haven't deployed it. So then you deploy your tiny little change because you're a new developer and you don't know much about the project yet. So you deploy your tiny little change And then what can happen is one person told me like, yeah, you accidentally run some database migrations that weren't supposed to be ran. And you change a field from a float to an integer or something like that. So really bad things can happen. And this is something that you sort of don't realize what has happened before it happens. So really something to be careful of. And if you can, just check that you know what's running before you push some new stuff there as well. Staging. Yeah, it would. That's. Of course, you're going to have different environments, or well, of course you should have different environments. It's not like you necessarily do, but that's not sort of. It doesn't help if like the production environment is different. You can check that staging is everything is all right, but there might be stuff in staging that isn't in production as well. So it doesn't really help with that. But yeah, definitely you should have a staging environment. You should have a development environment. If you're like doing everything perfectly, you have different environments per PR, so you can review your changes individually and like compare them individually, and then merge them all and check them on staging or test environment or something. But let's be real, nobody has that. So anyway, you want to run it, and where do you run it? Ooh, virtual hardware. This usually happens where like some manager or PO or something is like, yeah, don't worry, like I know you suggested Google Cloud, but we have this private cloud. You know what private cloud means, right? That's just like a server in a basement with some virtual machines on it. In the worst case, you might actually get like a server, but then, okay, then you have a server, cool. But what you really want is you want to have some cloud set up to do this, because then you can just spin up new machines, you can kill them, you can treat them as cattle, not as pets. All of this cool stuff that we've, especially you here have come to learn is really great. But what you can get at clients actually really still to this day is like undocumented virtual machines. I was talking to a colleague of mine who was in a project, and they had this ticket-based system where you could ask for virtual machines, and then you got basically an IP address and like username, password, and you had SSH access. And they were developing using this. It was actually running, I think, in the same building in the basement somewhere. And then they had some heavy jobs or something going on, and they had a memory leak, and so the SSH connection like hung up, and like the machine was out of memory or something. And they couldn't do anything about it because they only had SSH access. So again, they had to go to the ticketing system, make a ticket, can you please reboot this virtual machine? And they had to wait for like a week or two before somebody could reboot that virtual machine. So yeah, this is why you need to have a cloud set up. Well, once you get your stuff deployed, you want to have some users for it. And that means you need API documentation. Most of the rules for good documentation apply also to API documentation. Here, the same thing applies. It needs to be up to date, or it's just almost worse than useless. And this is something where you need to have that documentation, because if nothing else, you're going to need it. Because even if nobody else reads it, that just means that they're going to come to you and ask, like, hey, how does this API work? And you're going to need to have an answer. So it's much nicer if you can just document the API while you're doing it. That means your API clients get the documentation, you get the documentation when someone asks you for it. And I think the best way to do this is to auto-generate as much as possible of it. So just use whatever your language supports to sort of define how the fields look and what you can have there, and add examples, descriptions, and preferably define it in code. So that if it's missing or if it's incorrect, like if the documentation doesn't match what the function is actually returning, some compiler should tell you about that. That, I think, is the only way to keep that documentation even a little bit up to date. Because if you just write it on like a Confluence page or somewhere, that's going to be out of date before like your next feature is out. So define your API documentation in code if at all possible. And then you're going to hit cache bugs because you're going to have users, and your users are going to be using your API, and you're not going to have enough power in your little virtual hardware in the basement to handle that. So you're going to add cache. And as someone who just joined the company was putting up like a picture, I think it was from Spotify, where they had this poster about, do you need more bugs in your application? Try implementing a cache. That's really true. Like cache bugs are, if you have a cache, usually the bugs are related to the cache. Here you can hit on such nice things as, for example, infinite client caches, especially in web development. If you have your API and then you have something and you accidentally once put an infinite cache on it, that's going to be in your clients forever. Even worse if you have mobile apps, because anytime you put anything in the mobile app that relies on like the API, how the API works, you can never change the API after that. It's impossible to get rid of old app versions. It just is. Basically, the first thing you should do when developing an app is to develop the force update feature. It's also really easy with caches to accidentally leak private data. Just put like the shopping cart as one of the cached endpoints, and there you have someone seeing someone else's shopping cart. And you can hit some more really sort of sneaky bugs here as well. One I learned about not too long ago is you do everything right. You like don't do infinite caches. You have separate cache times as well. You have like 10 seconds for the front end, 20 seconds for the back end, and 30 seconds for the database or something like that. The problem with cache times like those are at some point, they're all going to sync up, and then all of the caches are going to be invalidated at the same time, and you're going to crash. So you actually do need to think about caching times quite a lot to get this properly right. If you can avoid it, just avoid it, or let someone else handle it. Also, no security. What bad API wouldn't be without no security? So for example, input validation. To this day, it's still very common to see SQL injections that actually go through. You're just going to have to hope that you don't actually have an SQL database somewhere that reads those. But it's like input validation really should be something that you do every single time. You should let the framework handle if it can. If you have a homebrew framework, that's a really good way to introduce security holes. Also, old libraries. What was the credit card hack in the US where they had a Struts version that was like 2 months old, and that was enough to breach 150 million customers or something. So just check your libraries and be sure you know how to check your libraries. That's also one thing when coming into a new project that you're not very familiar with. Like, how do you know what libraries have been used? You need to figure that out so that you're not exposing your users. And also, of course, always use SSL in production. But I would also suggest that you don't use SSL locally, at least not with self-signed certificates and stuff, because that's probably just going to introduce complexity, and then you might accidentally be using those certificates in production, stuff like that. API keys. You need to use them. And one point that I heard last time I did this talk was, you also need to keep track of your API keys. Apparently, that's not a thing that everybody does. So if you issue API keys, you need to know who has them so that you can ask if they're going to be using them, and so you can tell them that you're deprecating your API. So if you use API keys, make sure to keep track of them. And another example, your domain. You need to have your own domain. Because if you're running on something like Heroku and your app is something.heroku.com, then you're never going to be able to update that. You're always going to have to be running something on Heroku, because again, if you have clients depending on it, they're going to be there forever. All right, some more stuff. API management. This is actually a good thing. API management is a really good thing. API management means just having a system where you can define different APIs and sort of unify how they work. That's the idea of it. Usually how API management is done is you just have your API and you have your client and you put some unnecessary complexity in between. And you don't use it as the sort of platform where you can do lift and shift operations, where you can direct APIs to different places. So usually what you do is you just completely underutilize it. For example, Google has the Apigee API management, and it's really good if you use it properly, but it's completely sort of unnecessary if you don't use it properly. So if you're going to use it, it's a good idea, but make sure you know how to use it correctly and think about your users. Think about how the users are going to experience your API and not how it's easiest for you to implement the API. If you're going to do an API, just do it well. And there are really great tools like Apigee that can help you there. All right, some final thoughts. So just bad API properties. I'm going to just list a few. So status codes. Your API should never just return 200. Like, it's super annoying to have an API. It's called RESTful API that returns 200 and then error or something. So just use the status codes. They're there for a reason. And if you don't, at least don't call your API RESTful. So RESTful, again, is if you're going to call it RESTful, just make sure it actually is that. There are some specific rules about how to do it. It's not just that you're returning JSON. Just returning JSON does not make your API RESTful. You need to actually handle the different entities there with the different HTTP status codes, etc., to be able to at least pretend that it's RESTful. Errors return HTML. Yeah, someone has seen this. You usually see the error message where it's like complaining about the less than sign, because your framework by default outputs HTML on error pages, and you hit an error and you get the HTML sign. It's not that hard to put like a fallback there that returns JSON. No versioning. If you don't have versioning, that's going to bite you in the ass. It's not that hard to do. Just put something in the beginning where you can change it. So you have like V1 or something. It's really simple. And if you're going to return relative URLs in your actual API, if you're going to have like, for more information, check out this relative URL, make sure it's relative to the root of the version, not to the root of the actual API, because otherwise it's going to be very hard to change it later. Something I learned recently. There. Bad performance. Yeah, this is very common as well. Just make sure you're not asking for stuff that you don't need. You can have query parameters to tell the API to give you more information or less information. Just try to default to something sensible. And then get is not idempotent. The word is a bit tricky, but basically means that get should never change what you're getting. So if you get something, you should be able to get it again and again and again, and it should never change anything. There have been instances where you can do get/delete. That sounds like a very bad idea. And at some point, I think Google in Chrome was trying to optimize queries. So they were trying to like get resources before you went there so that they would be ready for you. And they went into like bad applications that had this sort of get/delete type of thing and just deleted a bunch of stuff for the user. So yeah, just make sure you can do get over again and always get the same response. And then finally one, this you see in some old SOAP APIs usually, is like field names in local languages. That's super annoying. Just at least stick to one language. It doesn't matter if it's all French, just make sure it's all French, because it's really difficult to have different languages there. So yeah, just basically make sure that the API is good for your API consumers, and it's not about you having an easy time implementing it, it's about your users having an easy time using it. So, what can you do? Just always remember that there is, or there at least was, a reason for whatever really stupid thing you happen upon. So when you see something and you're like, oh my god, this piece of shit was written by a complete idiot, just remember there was a reason for it. I mean, there always was a reason for it. Maybe it was done by like a summer intern, like a 16-year-old who didn't know any better. Maybe it's like 20 years old and they didn't have any of the tools we have now. Or maybe the original purpose of this service was something completely different from what it's doing now. I've seen most of these things. There's always a reason, but it's not always a good reason anymore. So you need to ask why. You need to figure out like what was the original reason for this and why are we still doing it? Do we need to still do it? Can we change this? Can we just skip doing this stupid thing and do something else instead? And once you find out the reason, just document it. Put it somewhere in some code or put it somewhere in some README so that just think about when the next person comes there and is like, yeah, do this feature, like renovate this haunted house. Like how did it go for you? And where could you help that next person make it better? And finally, when everything goes to shit and you're just fed up, have a backup plan. So for example, I've been talking about this with my friend. His backup plan is to become a florist. I like that. Flowers are pretty, they make you happy. Have a backup plan. Thank you.